Hi everyone, welcome to the channel with Buzz with MXN. Today we're going to discuss the topic on computer networking. The topic for today is DHCP, which is Dynamic Host Configuration Protocol. So we will learn about what we are going to learn about in today's lecture is why we basically needed DHCP in the first place and what is it about and how we can use it in configuring our networking equipments. So let's get started. So what exactly or what basically DHCP is? DHCP basically is a dynamic host configuration protocol. It's basically a networking protocol that dynamically assigns the IP addresses to the host inside your organization or whichever company you're working in, or whether you're at your home and you want to connect to the internet. So you would need a DHCP server for connecting to the outside network. So that is what the DHCP or the Dynamic Host Configuration Protocol does. It helps you assign the client or the host an IP address so that it can basically communicate with the outside network or the outside internet. DHCP also assigns domain name system. These are the components that are assigned by the DHCP, that is the domain name system or the domain name system addresses, subnet masks, and default gateway, and many other things that are basically assigned by the DHCP. One may be asking as to why we basically needed this DHCP in the first place. That's a pretty valid question, and assume I'd like to give you an example for the same. Assume that you are basically trying to configure your network. You're trying to connect to the internet. To connect to the internet, you would basically need an IP address. For example, let me give you an analogy for this. For example, I want to send you an email or I want to send you any posts to your address where you're residing. Until and unless I do not have a complete address of where you are residing at present, I won't be able to send that post or whatever information or piece of information I need to send via email or via mail to your location. So similar is the case with DHCP. Unless and until you don't have a specific IP address over the internet, you won't be able to communicate with the outside network or your address is not fixed. So this is the main task of what the DHCP does. Uh, so why is it necessary? Why cannot we do it manually? Of course, we can assign the IP addresses manually as well. Uh, like, for example, you have two or three end hosts, like you have a laptop, you have a mobile phone, you have a printer inside your home, and you want to connect them through your router. So you can basically go ahead and manually assign the IP addresses with their respective subnet masks, and it would be configured. But get yourself, for example, understand this, like you're working in an organization or you have an office work where there are multiple servers, multiple end hosts that needs to be connected over the internet. So in order to make the connection possible, in order to assign the IPs to hundreds of servers, hundreds of end hosts, we cannot do that manually. That would be actually a tedious task for us to configure that manually. That is why we basically use the DHCP to dynamically assign the IP addresses. And there is one more fault that if we assign the IP addresses manually, we may have an IP conflict. An IP conflict is nothing but assigning a same IP address to multiple users or multiple end hosts. That would result in a network down situation and that would not be very helpful for us. That is why the DHCP is basically used. Uh, Talking about how the DHCP works. So there's an acronym that is used, that is DORA, or we basically that the DORA basically represents the discover, offer, request, and acknowledge messages. So there are four messages that are basically shared between between the DHCP client and the DHCP server. Example of the DHCP client is, for example, your laptop that you're currently using, and the DHCP server might reside somewhere over the internet. The task for the DHCP server is to assign you an IP address through which you would be able to communicate to the outside internet or the outside network. So how that is done? That is done via the via the DORA process. What is this DORA process? So there are four messages that are being sent. For example, starting with your end host or the end client, that is your laptop. The laptop, for example, you acquire a fresh laptop, it hasn't been connected to the internet before. So what it does, it sends a discover message. It's a client broadcasts a message to the to discover a DHCP server. For example, your client for your laptop basically sends a broadcast message over the internet of like asking, hey, I am the 123 for my I am this I am a laptop and I want to communicate with the outside internet. Can the can I know where the DHCP resides and can I get an IP address for the same? And your DHCP server, once it gets the message, what it does is basically it offers an IP address to the laptop or the end user, that hey, this is the DHCP server and here is the IP address that you are requesting for. It basically has a particular pool of IP addresses. Like for example, whenever we have a DHCP server, we have a particular pool or scope of IP addresses that is assigned. Within them only, it is basically able to assign an IP address. For example, the range is from 192.168.1.1 to 192.168.1.50. So there are like 50 addresses that can be assigned to the end user within which are not currently in use. So any of the IP addresses it picks up and uh, offers the client, the DHCP client. And what happens next is the DHCP client gets the message and requests the client for the particular IP address. For the end host is like, okay, I got the message, I got the IP address, and I want it for my system. Can you please assign it to me? It's a request that is sent from the DHCP client to the DHCP server. That's what is written, like client selects an offer and formally requests to use the IP. And once the request is sent to from the DHCP client to the DHCP server, the DHCP server acknowledges it and then formally sends and allocates the IP address to the client itself. So when this is done, the DHCP server formally assigns the IP, whichever is available in the pool of IPs in the DHCP server, it assigns to the client, and the client gets the IP address through which it is basically able to communicate over the internet. Uh, there are various factors, there are various things that are given by the DHCP server to the DHCP client, and that contains the DNS server name, address, the subnet mask, and the IP address itself, and various other things that we will discuss further. So there is a term called DHCP scope. So what is a DHCP scope? It's a dynamic host configuration protocol. A DHCP scope is a range of an IP address that a DHCP server can lease to a device on a subnet. The DHCP server uses the scope to manage the distribution and assignment of IP addresses to the client. So as it is stated that DHCP scope basically has a range of is a set or a range of IP addresses that the DHCP server can provide to the end host on a particular subnet. The DHCP server basically uses the scopes and to help distribute the or assignment of the IP address to the client. For example, you have your laptop and you want to connect to the internet, you will send the requests to the DHCP server, DHCP query to the DHCP requests to the server for the IP address, and the DHCP has a scope for a particular subnet. For example, you reside in a specific subnet on the internet. So what it does, it basically assigns you an IP address from a scope of IP address ranges that is particularly has. That is basically the use case of DHCP scope. And talking about what the DHCP scope contains in general, a DHCP scope contains the following information. That is the IP address range. It contains a subnet mask. It contains a scope name, a lease duration, a DHCP scope options, a DHCP server. So as you know, that IP address range, as I stated, that is the IP address range that is assigned to the DHCP client. There are various ranges that may be dedicated for a specific subnet. So this DHCP scope basically helps contains the IP address range through which of which one of the IP addresses is assigned to the client. Also the subnet masks that determines the prefix that is given to the IP address. It's 255.255.255.0 if you're using a class C address, or a class B subnet, or any other class A, for example. So it contains the subnet mask information, also the scope name that can be automatically assigned when a scope is created. Lease duration is another thing. For example, a particular IP address is assigned to any of the end client, any of the DHCP client. So once the client is no longer using the IP and is currently in off state or is not connected to the internet, there is a particular lease time, like it can be 3 hours, 8 hours, defined in the DHCP scope, as defined in the DHCP scope. Based on that, the DHCP client, based on that, the DHCP lease duration, as it is set, the IP assignment expires, and you would have to request the IP again from the DHCP server in order to continue working. So these lease duration is a very important thing, as it helps in renewing the IP addresses. So the IP address is not stuck with a particular client itself. For the DHCP scope option can be configured for assignment of DHCP clients such as DNS server, routers, and default gateway IP addresses. I guess that is self-explanatory. And the DHCP server automatically provides the IP addresses and other parameters to devices that connect to an internet. So this is a short summary of the DHCP, what this DHCP scope contains. So additionally, uh, as we have already shared what it basically does, there are various other things that are contained in the scope. For example, you want to uh, you want to basically have an excluded range of IP addresses that you do not want to assign to any of the other clients. For example, you want a specific IP that is dedicated to a printer, for example. So you can reserve that IP range for that particular printer, for example. So these are various other things. Also, there are various subnets that we have. The DHCP relay agent, we must know what that does. It's nothing but a router that is on your internet that you're connected to. It acts for example, there is a broadcast message. The first discover message that is sent from the client, DHCP client to the DHCP server. For example, if the DHCP server is not present on the same subnet on which your client is, so as it is a broadcast message, that the router would not forward that message to the DHCP server. In order for that, you need a DHCP relay agent. A relay agent basically works as an intermediary between the DHCP client and the DHCP server that are not on the same subnet or the local network. So, for example, the subnets are different. DHCP is on a different subnet, and the DHCP server client is on a different subnet, and the DHCP server is on a different subnet. Then we make the use of DHCP relay agent. The DHCP relay agent basically forwards the DHCP broadcast messages from clients to remote servers, letting clients obtain IP addresses and other network configurations information from the DHCP server located on a different subnet. So this was something I wanted to share regarding the DHCP. Hope you liked the session, and if you have any questions, leave a comment below. And I think I'll continue from with my video lectures and help all the other individuals on this channel to basically know about more about the computer networking, and I guess it would be helpful for future. Thanks for listening. Have a good day. Bye bye.